Hello geographers and welcome to this video on river processes. This is the second lesson of your rivers part of your physical landscapes topic, and what we're going to be doing today is looking at erosion, transport and deposition within a river. So by the end of the lesson you should be confident in the 4 types of erosion, the 4 types of transportation and the reasons why a river will deposit its load of sediment. So let's start off with erosion. What I would like you to do in a moment is you are going to watch a recap video which focuses upon river erosional processes. You will notice that these erosional processes are the same as the ones that you get in coasts, but it's really important that we appreciate that this is a different body of water that is acting as the erosive tool, and therefore we need to just change the wording of these a little bit to suit rivers. So I'd now like you to pause this video, watch video link 1 in the description box, and then come back to me once you are ready. Okay, so hopefully that link worked and you've got a nice clear overview of those erosional processes. What I would like you to do now is take the part of your workbook that looks a little bit like this slide here, and you're going to be popping these terminology definitions into the right section. So for example, you are going to look for one that is defining hydraulic action, and then you're going to follow that all the way through that worksheet until you have them in the correct place. I'd like you to pause this video whilst you give this a go, and then you're going to unpause when you are ready to check your answers. Okay, so let's have a look at these one by one. So reading the first one, rocks within the river strike each other as well as the river bed, which makes them smaller and smoother. Now you might have noticed that that is very similar to what's happening in the coast when you have got waves moving sediment around, and those pieces of sediment, whilst they are in suspension in the water, are breaking up. So it's exactly the same key term. We have got attrition. Let's have a look at the one on the right hand side at the top here. So this is the shear force of the moving water. The water can force air into cracks in the bed and bank which remove loose material. So you hopefully spotted that that one was hydraulic action. Of course, you can also call it hydraulic power. Note the difference here in terms of the river's definition versus the coast's one. We need to be definitely not using the word wave, but also referring to the bed and the banks of the river rather than the cliff. So it's just a little bit of a shifting of the way in which we're writing about these definitions. Okay, bottom left, the scraping, rubbing and scouring action of rocks carried by the river. The flow of the water drags the load against the bed and banks. So notice we've said flow of water here, not wave. And the answer for that one, of course, is abrasion. So that sandpaper effect of the sediment rubbing against the bed and banks, just as it would have done on the coastline, perhaps on a wave-cut platform. Final one then, so obviously we've got one left and this is solution. So minerals in the rock are dissolved by weak acids in the river water and carried away in solution. This is again going to be the most active on any rocks that are quite heavy in terms of their calcium carbonate content. So things like limestone are going to be very susceptible to solution in a river too. Okay, let's have a little bit of a think about our transport. So exactly the same concept of hopefully appreciating that we've covered these words before, but just making sure we can talk about them in the context of a river. So again, we've got one of the brilliant Time for Geography videos that I'd like you to be watching now. So if you pause my video, go to the description box, click on video link 2, and then join back with me when you are ready to fill in this part of your booklet. Okay, so same process. I'm now going to leave you with these key terms here, and I'd like you to just put them into the correct box, pause the video again, and then join back with me when you are ready to go through your answers together. Okay, so let's go with the first one. Small stones bounce along the riverbed. They may be picked up from the bed and dropped again a little further downstream. So the key term here that should be giving you a bit of a hint is the reference to bouncing along the riverbed. So it's going to be sediment that isn't really big, So the river can, perhaps in high flow when there's maybe been lots of rain or perhaps a storm, lift this sediment up and allow it to bounce a little bit down the river, but it's obviously not going to be able to lift it up completely. So this one is saltation, that bouncing movement. Okay, top right, large stones, so much bigger this time, and boulders are dragged along the riverbed by water moving downstream. This process operates only at times of very high energy. So with this one, what you should hopefully remember is that the rolling movement of sediment is referred to as traction. And with that, obviously, the way that it's working out ways to remember it. So I remember that if you think about the traction of a tyre, tyres obviously, hopefully, are rolling along the road. They're not jumping or being suspended. Or some students like to remember it as a tractor because tractors are very heavy and they again roll across the surface. So finding ways to remember those key terms is always helpful. Okay, bottom left, very small particles of sand and silt are carried along by the flow of the river. So with this one, obviously we've got much smaller sediment. So in coasts, this could have been sand, and it could be something that is quite sand-like within a river or just smaller particles of soil. And what's going to happen there is obviously it's going to be able to be lifted up because it's much lighter and carried along in the flow of the water. So this one is suspension, which means again we have got solution left. So remember, solution is an erosional process, isn't it? Because often it's that process of dissolving, which is the erosion bit. But once it's actually in the body of the water, in the river, then it will be moved as well. So it's almost the continuation of that process. The next step is obviously it's going to move within the water it's been dissolved in. So solution is also a transport process as well as an erosional one. Okay, so make sure you've got all of those done. You can, of course, be pausing this video again if you need to change anything, but we're now going to have a little bit of a think about deposition. So deposition occurs within our rivers, and actually it's a really important process of landform and landscape sustainability. We need our rivers to transport and then deposit sediment. River sediment is fantastically fertile, which is why you'll find a lot of farmland often exists on the floodplains directly around a river. So we need to think about why rivers are going to drop sediment. So things are obviously going to change. Maybe this river has picked things up and then it has, for whatever reason, got to a situation where it needs to drop it. So what I would like you to do is just have a little bit of a pause of this video for a moment. Using the pictures, give yourself a little bit of thinking space. What might have happened to the river, on the river, which means that it's going to eventually, or for at least a small part of time, deposit sediment. Have a think about that and come back to me when you're ready. Okay, so hopefully you've had a little bit of time to think about what might be going on in these pictures or reasons why a river might deposit sediment. So just to make sure we're happy with the definition of what deposition actually is, because it is the same as what we discussed when we were talking about coasts. But remember, it's just when a river is going to drop any sediment that it is carrying. So there's a few reasons why this might happen, and we're going to go through these together. So the first thing to note is that all of these are going to be factors that lead to a loss of river energy, or just that the energy within the river is not enough to hold the sediment. So if we think about why that might happen, the first thing is that the gradient might flatten out. So if a river enters quite a flat bit of land, then it's going to lose that gravitational potential energy, the energy that pulls something down a hill. So that's going to slow and reduce, and that could potentially lead to deposition. Another thing might happen is the river will perhaps meet the sea. Now, if you think about what you've probably looked at in physics in terms of opposing forces, if you've got forces coming together but they're in opposite directions, they can cancel each other out. And that is exactly what happens at the end of a river. As it meets the sea, obviously the waves are coming in the exact opposite direction, and then you get the cancelling out of both of those energies, and then river sediment is dropped. It's also worth noting that sediment from the coast can be dropped then as well if the waves were also carrying things, which is why we end up with things like spits and the mudflats that exist behind them. So meeting the sea is going to cancel out that river energy. Another thing that might happen is if we have a loss of water in the river. So say there's been a particularly dry period where we haven't had a lot of rain, then that's going to reduce the amount of water in the river, which the official term for that is river discharge. So if that reduces, then for lots of complicated reasons to do with the amount of water in contact with the riverbeds and therefore affected by friction, if you've got less water in a river, it's going to slow that river down. Another thing that will happen as well is in the opposite situation where you've got lots of water in the river, then the river might actually overflow and it will spread out onto flat land. Now, if you think about a river spilling out onto a field, for example, on the floodplain, then there's going to be lots of friction involved as that river spills onto that grass or whatever it is that's on the actual floodplain itself. And of course, it's going to slow down as it moves away from the river channel. So that will again potentially lead to deposition. Like I said, that is really, really important for the nutrition and quality of our soils, that we actually allow that to happen sometimes. And another thing as well is that rivers can slow down as they move. So not because they've reduced the amount of water or anything like that, but if they go around a meander bend, then the inside of that meander will actually slow down in terms of river energy and river speed. When we look at meanders as a landform, you'll understand that in a lot more context. But just note that in some parts of a river's journey, it will be forced to slow down as it's going around corners, for example, and we will make sure we cover that in lots of depth when we get to meander formation. So lots of reasons, but ultimately, all boil down to the same thing, the idea that the river will lose energy. It's worth noting as well that what can also happen, which we will have discussed in coasts, is you can sometimes get something like a small kind of river cliff collapse. So if the bank of the river collapses and you get lots of extra sediment, then of course there'll be too much sediment in the river for it to carry. So that will also lead to deposition. So what I'm going to get you to do now is attempt this part of your booklet based on what we have just been talking about. And we're going to just do the following things. There's two bits of this task. The first thing is to summarise what deposition is. So a sentence for that will be absolutely fine. And then some examples of what we've just spoken about. So why does it happen within a river? What conditions will lead to the process of deposition? Pause this video now, give this a go first, and make sure you do this because this is a really important part of your learning process. And then if you unpause when you're ready to go through this with me, you can just check my example answer that's about to come up here and perhaps use it to improve your own if you find any gaps. Okay, pause this now. See you in a sec. Right then, let's go through this together. So hopefully you've got something written onto your paper now, and we're going to go through bit by bit. So the first thing we need to do is just remind ourselves what deposition is. So what you can have here, it is something like deposition is the process of a river dropping its load of sediment onto the riverbed or sides of the river. Banks would have maybe even been a better word to use there instead of sides. So that's the first bit. Now we need to just show that we understand why deposition happens. So read with me, and like I said, you can use this to improve your answer if you feel that there are any gaps or you need to just improve those notes a little bit. So the first thing I've done here is I've mentioned energy. So it often happens when a river loses energy, which can occur due to many reasons, such as the river slowing down on the inside of a meander or spreading out over a floodplain during a flood. When a river meets the sea, the incoming waves will cancel out river energy too. Deposition can also occur if there is suddenly more sediment, so for example, a river cliff collapse or less water due to something like a drought. So I've tried to include as many of those examples as I can within this short piece of writing, and I'd like you to just check that you have made reference to what the definition of deposition is. You've spoken about the loss of energy being the main reason, but then given at least 3 examples of ways in which rivers will lose energy. And then I think you're pretty much there in terms of this task. Okay. So we've actually done everything within our 3 types of processes: erosion, transportation, and deposition. But I thought I would take the opportunity today to also get things set up for our next lesson, because next lesson we are going to be looking at the processes involved in the creation of waterfalls and gorges, and they are landforms created in the upper course. So I'd like us to think about the processes that we've just learnt today, and how they actually are at play, how they're working in the upper course. So these are the questions that we're going to work through together after I've given you a bit of thinking time, and they are as follows. Why is the river winding around? So if you see, it's kind of going around these kind of lumps, I suppose. I don't want to give you any key terms at the moment because I don't want to give too much away, but there's almost like lumps in the kind of shape of the river valley there. So it's having to wind around those. I want you to think about why the valley has this shape. So you can hopefully see it's a V-shaped valley. So why is it a V shape and not the opposite of that, which is a U-shaped valley? I want you to then have a think about why the river is narrow or shallow, and shallow really. Why is the river not much bigger and why is it not much wider? And then you can see within this image, although I appreciate it's not zoomed in enough to get the clarification on this, that these rocks they look quite big, don't they? So they're quite large, and you can be assured, even though you can't see it, that they're actually quite angular as well. So they're quite jagged. So what I'd like you to do now is just look at the next part of your booklet where you have got these 2 images, and I'd like you to just pause this video and see if you can finish any of these sentences. The more you can do, the better, so that you're not directly copying from my examples in a moment. But see if you can start to answer those questions using the sentence starters on this slide. Pause this now and then come back to me once you've given it a go. Okay, so let's go through these then. And like I said, this is just us trying to use our knowledge so far to set the scene of the upper course, ready to look at those waterfalls next lesson. So first one on the top left, the river is narrow and shallow because. Now what you've hopefully noted is that this is actually the start of the river, and we know that rivers start small, and as they get lots of tributaries joining them, so those little rivers that join onto them, and as they drain more and more water from the land, they get bigger and bigger. So the answer to this is actually it's so close to the source in the upper course that it hasn't had time to build up that supply of water. Question here, or rather the sentence starter. The rocks here are large and jagged or angular, and this is because the rock type is generally really resistant in the upper course. That's why it's managed to stay quite high up in terms of our landscape, and it hasn't been eroded by things like attrition yet. So that explains why they're not nice smooth rocks. These rocks are not going through those processes of attrition that would be experienced further downstream with those larger rivers at play. The next one, the river winds around these hills because. So something to note is that, as I said earlier, this is quite hard resistant rock in terms of this landscape. So because the river is so tiny, it's very narrow, it's very shallow, it's not actually going to have the ability to erode through the landscape. So if it comes to a hill, or as we should call them here, a spur, and it's too resistant, it's going to have to just go around it. Okay, so that's ultimately why it is winding around these interlocking spurs. That's what we call these kind of hills that, as you can see from the diagram at the bottom, do interlock a little bit like a braid. So they are referred to as interlocking spurs. And the last one, the valley is V-shaped because. So erosion is mostly vertical. If you remember from lesson 1, there's lots of vertical erosion in the upper course because it's quite high up. So there's a lot of gravitational pull downwards on the water. So it's going to erode downwards rather than laterally from one side to the other. So as a result of that, it will be eroding in a very narrow channel. And of course, as a result of that, the sides of that channel are going to be quite steep, and that's why you end up with a V-shaped valley. Okay, so this is pretty much everything we've just said. You're more than welcome to pause and just check your understanding of that. But hopefully, if you manage to keep up with those conversations and notes, you will be fine with that stuff. Okay, so what I would recommend you do now, just to check that you're happy with everything we've looked at today, is I'm now going to display a list of statements, and I'd like you to just run through them. You can jot these down in your rough notes in the back of your booklet, and just see if you can work out which key term each of these is referring to. So if I just get all of them on there for you now, I think there are 13, unlucky for some. If you just pause this and then just do 1 to 13 in the margin of your rough notes, and just check that you are able to kind of go through these and assign them to a particular type of process. You can pause this now, and then what I will do is I will also show you the answers in a second. Okay, so pause, give it a go, and then come back to me when you are ready to check your answers. Okay, so well done for giving that a go. Let's go through those answers. So number 1, erode the riverbed through friction is abrasion. Number 2, minerals being dissolved is solution. And I've put an E in brackets there because it's talking about the process of the actual dissolving. So it's the erosion, not the transportation of stuff that's already been dissolved. Stones hitting each other is attrition. Pebbles bouncing along the riverbed is saltation. Air forced into cracks is hydraulic power or action. Doesn't matter which of those, hydraulic action or hydraulic power, that you use. Sand being carried in the water is suspension. So it's being lifted up by the actual water itself. Happens underneath waterfalls. So this one is going to be more hydraulic power in action. If you think about the force of the water coming down from that waterfall, it very much will be the force of the water at play. Sandpaper effect is abrasion. Boulders rolled along the bed is traction. This one is also traction, process of transport that only happens when the river energy is high. You need a lot of energy to be able to move those big boulders. Happens because river water is slightly acidic is solution. And then 2 situations which would cause deposition. There were loads, weren't there? But you could have mentioned rivers bursting their banks in a flood, or rivers getting to the sea. Any of those that we discussed in that bullet pointed list earlier will be fine, but you have to get 2 to get the mark. And the last one, makes pebbles smaller and smoother is attrition. So one thing to note is that every single year we get feedback from the examiners about what students do really well and what they struggle with. And this is nationally, not just within our school. And one of the things that is mentioned is that in the physical geography topics, although you clearly know what you're talking about as geographers, what students have previously failed to do sometimes is use this terminology either correctly or wherever possible. So instead of using the word erode or transport, really think about whenever you're using those erosion, transport or deposition kind of parts of your explanations. Perhaps you're explaining how a waterfall forms once you've done that lesson, which obviously you haven't done yet, is to really make sure you think about what type of erosion you're talking about, or exactly how that river is transporting sediment, rather than just using the word erode or transport. A lot of students like to make little activities, so revision cards which have got one of these key terms on one side and the definition of it on the other, and that tends to really help them in remembering what is quite a lot of geographical and very specific terminology. Okay, so if we just finish there, just a reminder of what we were doing today. So you should hopefully now have your booklet finished with erosion, transportation, times 4, so 4 different types of those, and you've got your written element of why deposition occurs. And of course, like I said, we've also just set you up a little bit ready to look at waterfall formation by looking at the characteristics of the upper course and the processes going on there. Okay, so thank you very much for watching this recorded lesson today. I hope that has all been helpful, but don't forget your teachers are always waiting in the wings to help you if you have any questions or need anything going over again. And I will leave it there. Have a brilliant day, geographers.